Alright, welcome to my tutorial on PhET Colorado's circuit construction simulator kits. So before we get started, I just want to make sure that we all know how to get to the correct simulator, because there are a couple tricks to it. So when we're looking it up, we can either look up the PhET Colorado physics simulators, which should take us right here. It should always have this logo here, the PhET logo. So we have our physics simulations. The other option is we can also look up electricity simulators. It should take us right here, electricity, magnets, and circuits. So the key thing to note there is that we don't want to go straight to the circuit construction kits, because some of them will work and some of them won't. So if you just happen to click on a link for one that doesn't work on your computer, such as this one which doesn't work on mine, then you might get kind of frustrated. So instead, let's make sure that we click on either the physics or the electricity. If we do click on the physics, we then have to go to the subcategory of electricity, and here there are 4 different circuit construction kits. So like I was mentioning, some of them will work on your devices, some won't. There's 2 different main softwares that they run. This one down here, I'm not quite sure what it is. And we also have 2 kits here, this one here, and this one up here, which run on Java. So between the 4, they're all almost completely identical, but some will work on your school's devices or your home devices while others won't. So for instance, a school I was at in the past, their iPads would run with the Java, but they refused to run with this other software. Whereas my computer, on the other hand, can only run with these 2. So as I was mentioning, they're almost identical, but there are some slight differences. I personally prefer this one, the one that is not the virtual lab. I'll show you why as we go along. So if the software wasn't running, you wouldn't have gotten a loading screen. It would have just been blank, or you would have remained on the home page. So here it doesn't matter what we click on, because you can always jump back and forth. With the lab, it just includes some more complex elements, such as the wire resistivity, the battery resistance. But I prefer, especially if we're working on an assignment that doesn't include those, just go with the intro. If you're accidentally messing around with these and you change it, then it's going to mess up all your results for your equations. So if we go here, it's very simple to set up a circuit. You just take our battery here. If you hold it in the middle, you can move the entire object. If you hold it by a ring, you can rotate it. So we just click and drag from our toolbar anything that we need. And once again, you can hear the red ring you can use to elongate or pull a wire, rotate it. You'll notice here these rings have gone black. That shows that it is properly connected. If your circuit isn't doing anything, you're wondering why, make sure that all the joints are properly connected. You can also always disconnect them with the scissors. So once again, in the middle you can move the whole thing. If you just want to move an end, click the red ring and connect it. So now I'll grab my battery here, not my battery, my light bulb, and we now have our simple series circuit. Alright, so what you can see here is the flow of electrons actually moving through the circuit. So up here on the top right, we can either hide that or show it, or we can actually switch it to conventional. Which of those you want to use is up to you. The animation will change the same depending on current, whichever you choose. We also have the option of getting rid of labels on our toolbar. Not quite sure what that benefits, but it is an option. The last option is to include our values. So the value of our battery and the value of our light bulb. So we also can simply change our values here. So if I wanted to increase the voltage, we can now see the electrons go faster. The conventional will also go faster. And we have more light, more energy being produced. Similarly, on our light bulb, we can change our resistance, and as resistance increases, we're slowing down our current and producing less light. What's also kind of nice is if we bring it all the way down to 0, we will actually short circuit the circuit and our battery will go up in flames. It's a nice little illustration of why it's important to have a professional do your wiring at home, because short circuiting can be very dangerous. Alright, let's get this a bit more reasonable again. It's worth noting that you can also connect several wires to the same point. So here, if I wanted to connect 2 more wires, another light bulb, it would work perfectly fine as a fully functioning parallel circuit. So this is a perfectly valid way of doing it, but I prefer a bit more of a longer approach, which leaves us with this nice series circuit here. We also have the option of changing between common symbols and our scientific symbols. So let's get rid of our current so we can see it a bit better, and we have our battery, we have our light bulb, we also have our resistors and switch. So this can be very good if you're trying to memorize what the symbols are. You can create your circuit using what you know, and then you can check it with our scientific symbols. So here we see one of the reasons I like this kit better. It's because we are including our ammeter in 2 different ways. So we have 2 ammeters here and we have 1 voltmeter. So with our voltmeter we can check the voltage of our series quite simply, and here you'll notice that I have a negative, and that's because I have to make sure that my negative is on the negative end and my positive on the positive end, and then I'll get my proper positive result. So with the ammeter here, I really like this one better because you can just hold it over the spot that you want and it will tell you the current of the circuit. On the other hand, with this one here, we actually have to cut into the circuit and install it where we want it. So, same result, but this one's a lot faster, a little bit less work. And that's one of the reasons why, that's probably the single reason why I like this circuit better. So if we go here, we now have a nice parallel circuit, and here we can see that if we go down in the toolbar, we have some more options. So these 3 options, the battery, the light bulb, and the resistor, these are heavier duty options. So if we get rid of our battery here and we install our heavy duty battery, we're actually going to get a lot here because it is at a very high voltage. Same with the light bulb. This light bulb has very high resistance and this resistor is very high resistance. So I've now actually switched over to the construction kit DC Virtual Lab, which is why there's only 1 ammeter. So this is the one I don't like quite as much. If you go back here, you actually won't see the heavy, if you go back here, you won't see the heavier duty battery and light bulb because you have to switch over to the lab to use those. But anyway, now that we're back here, I'll actually reinstall this. And one thing that's kind of interesting to see here, let's break this up a bit, is, actually let's keep that cut. If you go further down our toolbar, we have all these interesting objects here. And you can, they're all resistors. So if you check over here on scientific notation, we'll always see resistors, scientific symbols. But the benefit here is there's a bunch of cool stuff, and it all has different resistances. So see here the dog, this is actually a fully connected circuit. Even though I left this one red, it is still fully connected. But we don't have any flow. So this can be a little challenge for students, but it's always a bit easy to cheat and just show our values and see that dogs have very high resistance. So similar to all the other objects, they all have a different resistance that isn't, you can't see it by clicking on it, so it can provide a bit of a challenge, have students solve using Ohm's law what is the resistance. So that's one of the other big benefits of this, is that you always have the exact number that you're looking for. With alligator clips, it's kind of difficult to do some equations because you don't actually know what voltage the battery is. A lot of these science kits, the batteries can be quite a bit older, so a 9-volt battery might only have 8 volts, and you might not know the resistance of a light bulb. So with these simulators, you always know the exact numbers you're dealing with. The other big benefit is you can use them anywhere. You don't necessarily need alligator clips, which are very specific, and schools often only have one set to do it. So, I hope you've enjoyed this tutorial and that you now feel confident in using PhET Colorado's circuit simulator.